So hello everyone, welcome back to the another lecture. My name is Ashish and today we are going to see one of the interesting video in power electronics which is about the sensing circuits. Okay, so we have done lot of simulations. You have seen that we sense directly the output voltage, we sense the inductor current, right? But when we go for hardware implementation, that time it is not that easy. We can directly tap the wire and connect to the control board, right? So there are some procedure which we need to follow. There are some ICs which we need to know which ICs to use and all. Okay, so for that I am going to make two videos. First video is on the voltage sensing in power electronics and another video is on the current sensing in power electronics. So this particular video we will talk about the voltage sensing in power electronics. Okay, so what things we are going to cover is what is the requirement of sensing units, right? Why can't directly we connect our output voltage to our control boards and all? What are the different methods are there to sense the output voltage or any voltage which we need in our control unit, and what are the different ICs and modules available for the voltage sensing? Okay, so this part we are going to cover. So the overall motto of this video is to make you familiar with what exactly we needed, okay, when we go for such kind of things. Okay, so let's get started with this video. So voltage sensing requirement. So what is the requirement of the voltage sensing? So let us say we have our buck converter. Okay, so inside the output I get suppose 100 volt. So why can't I directly connect? So if this 100 volt this is overall my control board. So control board is either DSP or FPGA. So this is a DSP TI kit DSP board and this is a FPGA Intel this is a basically AMD FPGA. Okay, so these are the control board which generally used in industry or in academics. Okay, so now, so if I will sense this output voltage and give it to my sensing pin, so sensing pins are somewhere inside this particular board. So if I will directly connect this output, so what will happen? So these boards have the issue. What is that issue? These boards only take input voltage as between 0 to 3.3 volt and it produce the output between 0 to 3.3 volt. So this is the first thing which you should know. So this control board has its own requirement. It needs the output voltage or input voltage in between 0 to 3.3 volt. So if I wanted to sense some voltage, it should be between 0 to 3.3 volt. It should not be negative as well. Okay, so this is the first requirement. So this control board has this requirement, and then what will happen if my voltage is between 0 to 3.3? Then I will connect this to between the sensing pin and then multiplied with some suitable gain, then compare with the reference and then pass it to some pre-I controller. Then I will generate the PWM. These all things we are going to do inside the code. Okay, this code we will write it down in FPGA platform or the TI basically code composite studio. Okay, so this thing maybe you are familiar or you are heard it maybe or for the first time, but that is fine. So some control board is there and we just need to provide some sense reference sense output voltage to this pin, and then we can do the internal mathematical computation and generate the PWM inside the code. And then these two pins are there which will the PWM pins, and then I will give whose output is again between 0 to 3.3 volt. Okay, and then we will pass it through. So D is my isolated gate driver, and then gate to source I will give it to the my buck converter or boost any kind of DC to DC converter. So this is how overall process is. Okay, so you understood. But we can't directly connect basically my output voltage, and in practical scenario my output is not always going to be less than 0.3. Okay, so I hope so till this particular point everything is clear to you. So what I told you that we have a control board like FPGA or DSP. It has a different pin like input pin, output pins, some sensing pins, okay, and different peripheral pin. Its input pin is again requirement of the voltage less than 3.3 volt. Its output pin again has a requirement of the voltage 0 to 3.3 volt. Okay, so whatever PWM is generated, that is again between 0 to 3.3 volt, and then we will pass it through our what we can call gate driver, which will be amplify the our controller signal. Okay, so we have made one dedicated video on gate driver where what is the requirement of gate driver and all those things we have studied. So this is about the control board. So because of the control board we need some sort of circuit which will basically divide my voltage. So you can say that the option one, sir, I need voltage between 0 to 3.3 volts. So why can't I use the voltage divider circuit, right? So if I use the voltage divider circuit, so let us say my output voltage is 100 volt and I wanted to give it to my control board, right? So for giving it to the control board, what I will do, I have my voltage divider. Let us basically put a very high value of the resistance, suppose 500k, 10k. So very high value of the resistance is there, and this particular load is of 10 ohm, 20 ohm. So maximum amount of current will flow through this particular branch, right? And very less current will go through this. But as both are in parallel, so overall voltage drop across this particular branch and this particular branch will be 100 volt, right? But this is less value of the resistance, so I will choose this two particular resistance in such a way that the drop across this particular resistance is less than 3.3 volt. So okay, so if this drop is less than 3.3 volt, then shall I give it to my sensing unit? Okay, so this is the thought you should, this thought should be came in your mind, right? So okay, so I will just use the voltage divider and I will give to the sensing pin, then I can do the computation task inside the control unit and generate the PWM. So is it so, is it so simple? No, there is a one problem. What is that problem? We cannot directly divide the voltage and give it to the sensing unit. What are the issues? So we need some sort of a stage here which is required. This is called as a buffer stage. This is called as buffer stage, or we call it as the voltage divider ICs. Okay, so we need some sort of buffer stage here, like op-amp stage, which is required. And what is the use, what is the requirement of that stage, I will explain to you in detail. Okay, so what is the requirement? So what is my overall question is, if the divider voltage is already less than 3.3 volt ADC separate, why can't we directly feed it to the controller? Okay, so we have divided the voltage, then we should directly feed it to the sensing pin, right? Why we need some kind of voltage sensing IC or op-amp buffer before the controller? So before controller, why we need this buffer stage? Okay, so this is my overall question. So what is the answer to this? So we will see, there are some different points. If in future somebody asks you, you can answer this particular question. Okay, so what are the different reason for that, why we need some buffer stage? So first is the input impedance of the controller ADC pin. So what is there? So this control circuit, this ADC pin has its own some finite input impedance. Okay, if it is often in range of tens of kilo ohm. A simple resistor divider also had its own impedance, like 510k. So this is some impedance I am adding here. So what is the theory is that if the divider resistor is too high, the ADC sampling capacitor inside the controller may not charge properly during the sampling, causing inaccurate voltage reading. So this is the case. So what is the basically sampling capacitor is there inside this particular control unit. If the total my divided resistance is very high, then this sampling will not be a proper. And another case, if the divider resistor is too low, the increase the power loss. So if this divider resistor I am keeping less, then overall basically current division will happen, and basically more current will flow through this and losses will be more. So this thing I don't want. Okay, so for this reason I need some buffer amplifier here, buffer stage voltage sensing ID, which provide high input impedance. So this buffer stage has very high input impedance and low output impedance. So I need the ICs of this kind only, which have very high input impedance and low output impedance, ensuring the ADC see a clear accurate signal. Okay, so this is the first reason why we need some buffer stage. So in future if somebody asks you why the input impedance of the basically why the buffer stage is required, so you can answer in this way. Okay, so why directly we can't connect the voltage divider output to the my sensing pin of the controller. Okay, I hope so this point is clear to you. Now we will move to some next reason. Okay, so what is the second reason? Second reason is the noise filtering and signal conditioning. What is meaning of this? So power converter generates a lot of switching noise, ripple and spike. Okay, so this converter will generate, that we know. A simple divider cannot separate this efficiently. Okay, or if we directly use this voltage divider, it is not capable to suppress all this basically switching noises, ripple and spikes. So a sensing op-amp stage can include the low-pass filter, giving the controller a stable DC signal instead of noisy waveform. Okay, so if this buffer stage we add some filters and all, like the capacitors for noise cancellation and all, then we will provide the sensing pin a very stable DC signal. So this is the another use why we use the buffer stage. Then there are another reasons as well, like isolation and protection. So if I will directly connect this divided voltage to my sensing unit, so there is no protection between my actual controller and my basically actual converter, right? But if there is some buffer stage which may provide the isolation as well, so there are some ICs which have some isolation inside as well, so I can separate my controller board and my actual converter as well. There are few more reasons like the overshoot. So let us say this output is 100 volt, maybe it fluctuate, and because of the fluctuation my output voltage across the 10k register, my voltage is greater than 3.3 volt, then this my control board will damage because its requirement is 0 to 3.3 volt, and if I will give more than 3.3, my control board may get damaged. So all these things are there which we need to consider. Now next is basically accuracy and calibration. So voltage divider has its own limitation, like its tolerance is 1 to 5%, and if we have some buffer stage which can basically sometime which will improve the accuracy and offset correction and all, like sensing the AC signal. So it is from plus, let us say some AC signal is there, plus volt, plus 1, minus 1. So in buffer stage only we can offset it, like from plus 2 to 0 volt. So because my signal is what is requirement here, 0 to 3.3 volt, I not even require the negative voltage. So all this thing we can do in the buffer stage as well. Okay, so that is why we need the voltage divider IC. Then another reason is the flexibility. We can add the gain and attenuate it as needed. So as I told you about the AC signal, so those all things we can do here. Okay, so I hope so you understand what are the things and all till now. Okay, so why we can't directly connect the my voltage divider output to the control board. Okay, that is sensing pin, right? Now what are the options, what are the solutions? So first solution is the very simple basically voltage sensing IC. This is the OPA series, OPA-AX354 IC. So these ICs are there, okay, which use for voltage divider. In most of the power electronic application you can see the OPA series voltage divider circuits are used. Now the simplified schematic you can see here, it has basically input voltage plus V minus V, which is basically 0 to 5 volt or 0 to 4 volt you can give. Okay, then I have my plus IN minus IN. So whatever my sensed output voltage is there, that I will going to give to my plus IN pin, and I will take the output voltage with respect to the output is again just a buffer. So it is simply acting like a buffer circuit, right? So my and it is a op amp, so negative feedback I will provide. So output I will short with the minus of IN. Okay, and I am just simply providing the plus IN, which is my sense output voltage, and then these output like my V out and minus of V in I will give to my sensing unit. Okay, so output whatever I am measuring, that is with respect to the some sort of ground. So this is my minus of V in. So this is how we will do. So I will tell you overall circuit how it looks and all. So I just wanted to tell you that so OPA series voltage divider ICs are available, you can use for voltage sensing. Okay, so it will come with different packages, like this is a single op amp based IT, it is a two level 2 op amp based IC, so you can sense the two output voltage at a time. Okay, so I need only one supply plus V minus V, and then I sense signal is between is plus IN plus and basically INB. Okay, plus INB. So I will keep this two signal here, and I will take the two output which I can use for further processes, right? So this is the overall story. Now how to connect this in the basically control board. So supply requirement is there for this particular IC. So plus V minus V, I need the 5 volt, I told you already. And second is the cost. So cost is about 400 to 500 rupees. So it is a bit of costlier IC, but basically generally used for safer operation. Okay, now next is basically how to do the connection. So this is the overall connection diagram I have. So I have my buck converter, and this is my overall IC. Now I need to basically I will going to divide my voltage. Okay, 500k 10k, and then this one pin, so this is ground, and whatever coming to this minus of V in, that is also the ground. Okay, so you can see that this particular output voltage, which is the divider voltage, is basically with respect to the fixed reference, that is a ground reference. So this value is between 0 to 3.3, but with respect to some fixed reference. Now this sales output, I will take the wire from here and I will connect to my which pin, plus IN. Okay, so I have connected to plus IN, then my minus IN and output I am going to short because of the basically op amp characteristic negative feedback. So minus of IN and V out I am going to short, and this output I am going to give my sensing pin. Again, my this particular IC need one supply 5 volt, so ground and 5 volt. So this plus 5 volt I have connected to the plus V, and this ground I have connected to the minus of V. And then to the sensing pin, I told you that I am going to give the output with respect to the ground. So this minus of V I am going to give here to the sensing pin. Then I can do the further control, whatever the computation I require. Once my signal is available to my sensing pin, then I can do the different types of computations. Okay, so I hope so till this particular point everything is clear. So if you are going to use this particular IC, how you are going to use it. Okay, so you can do the connection in this way. You can divide it with some high value of the resistances, and then do the connection in such a way. Okay, so till this point I think everything is clear. But okay, so I told you that requirement of the voltage is 5 volt and cost is 400 to 500. But what is the problem with this particular IC? Okay, we have taken the example of basically DC to DC converter, where I am sensing my output voltage, and that output voltage is with respect to what? That output voltage with respect to the ground. So what is the problem with this IC is a common mode voltage. So what is the common mode voltage? So we are measuring the sensed output with respect to ground and giving it to the plus ion. You have seen in connection. But what about if the sensed output is a floating in nature? Floating in nature is what I wanted to say, like the case of the AC voltage, say between the phase and neutral of the AC main. So if my output is between the phase and neutral of the AC main, so what I wanted to say, this kind of arrangement. So this is my phase, this is my neutral, this is the AC. So can I directly basically add some two resistor 500k 10k and divide them? The division will work perfectly fine, and then directly tap the wire and connect to my plus ion. So is it so? No. Why? Because when we are doing in case of DC, its bottom particular leg is a fixed value, which is a 0 volt, which is my ground. But here in case of AC, this is not the 0, it will fluctuate. Okay, let us say it is plus 230 volt AC RMS, then this particular leg phase and neutral value will be changing. Okay, sometime it is positive, sometime it is negative, and that is why this leg is not stable, and basically its impact will be happen here as well. And this IC has a common mode voltage of basically minus 0.1 to 3.4 volt. So that is the case. Okay, so the common mode voltage will come, so you cannot directly connect such kind of arrangement here. So what you can do instead of doing this, so you can, so this thing you don't have to do. Okay, if you are using this OPA based IC, you can't connect in such a way. Okay, so this thing you have to keep in your mind. So what is the alternative to do? So this is the circuit. So what is this circuit? Again, my AC main is there, which is connected to some sort of circuit. Okay, now what I have done is that for phase I have connected the two resistors and with respect to one ground, and then I am tapped between the in between. Okay, so I am getting here less than 0 to 3.3 volt. For basically neutral as well, what I have done is basically I have added one more resistor divider circuit of some higher value here and lower value here, and then I have tapped between 0 to 3.3 volt. Then I am going to use the two different basically OPA ICs, voltage sensor ICs, and then this is going to be plus ion and this is going to be plus ion. Now at the output terminal I have the two signals which are basically separated. Now they are not directly connected to the my control board. Now I will take these two signals inside the control board, and then I can add them or subtract them, and based on that I can generate the one sinusoidal between 0 to 1 volt, or basically plus 1 to minus 1, plus 2 to minus 2. Okay, and then I can shift it as well, so that it is between 0 to 3.3 volt. So this is the another way which you can do inside the code. Okay, but you need to have this sort of arrangement. Okay, so though what I will say that OPA based IC mostly be preferred basically during the DC basically applications where the DC output is there, which is measured with respect to the ground. That time it is very beneficial. Okay, now what are the other options we have? So other option is, if you wanted to measure the output in such a way, you have to use the differential op amps. So what are the differential op amps? So there are a differential op amp available as well, which are not the OPA based. There are some different TI as well as various companies have differential op amp which have the arrangement in such a way that it will measure the differential voltage. Okay, so that time this basically problem of common mode voltage will not come, and you can use this. Okay, so this is the simple concept you can use. So you search for some differential op-amp which are there available, and then you can use those in AC measurement or sensing, right? What are the other options? We will try to find out. So there is a AC sensor, AC voltage sensor module. So this is very basically, I would say, with less cost, 85 rupees. So what actually this particular module is? So it is a ZMPT 101B type of the module. What this particular module will do, you can see that these two pins are there. So what we need to do, you can directly connect the two terminal across the AC to this particular thing, okay, to this particular plus and my this AC, not plus and minus, my phase and neutral connect here, and there are the 5 pins available here. So you need to give the 0 to 5 volt input here, and from here you will get the output voltage which is between the 0 to, whose mean value is 2.5. okay. So this basically particular module has a some sort of arrangement inside this which will give the output of 2.5 volt. Okay, so if you apply the 230 volt AC here, its mean value is 2.5 volt. So this, what this particular module have inside, so basically one transformer is there, one flyback converter is there, this is what I guess, and it will provide some offset as well. So your output, your mean value or your average value is between your average value is always 2.5. so this particular module you can use for AC as well as DC, but this is very of very low cost and maybe that not that much reliable, I guess. So that is why people use the OPA based ICs or some isolated, or I will tell you some more options, those are there. So these options generally used. But what I will recommend, if you are working on some Arduino board or some small sort of boards, you can use this AC voltage sensor module. So they are okay to use. Okay, so this is another way. If you have some cost cutting, then you can use this. So you can use it will work. Okay, I have used this, so it will work fine, but not for very large scale application. You should use this. Okay, you have to use some precise ICs only. Okay, not some module. Now next is basically other options. So there are the isolated voltage sensor with very high bandwidth. So if you have the isolated voltage sensor with very high bandwidth, then your all the problem will be solved. So few are I have listed out here, but those have don't have very high bandwidth. Okay, so these have, I guess, a bandwidth up to 300-400 kilohertz. But if you are working on some 100 kilohertz of the switching frequency in converter, then this will not work, because you need to have very high sampling frequency. So bandwidth is very important. Let us say you have 10 megahertz of bandwidth, 1 megahertz bandwidth, then you can easily use this. But isolation is there. But if you are working on 10 kilohertz, 20 kilohertz, that time it is fine to go with this particular isolated voltage sensor. Okay, these have the bandwidth I told you, 300 to 400 kilohertz, but they can use if you are working on 10 kilohertz, 20 kilohertz application. Okay, but for going for 100 kilohertz, 200 kilohertz, you need very high bandwidth voltage sensor. Okay, so this is the another option. So you can this is my request to you, if you know some isolated voltage sensor with very high bandwidth, you can just search on Google. If you get some part number, then you can share with me. Okay, so this sort of part number you will get, so you can share with me. Okay, so if you get, so I have searched a lot, I don't get the isolated voltage sensor with very high bandwidth, like up to the megahertz level, I don't have find out any. So if you get, you will tell me. Now next and last option from my side is, if you are working on some drive sides, like you have a switching frequency of 20 kilohertz, 30 kilohertz, then generally I have seen in motor application, maybe you have done while doing the labs and all in your during your MTech or BTech, they use some this LEM LV based series voltage sensor. So this LV series sensors are also there. This looks like this. So these are the Hall effect based sensor. So these are isolated voltage sensor which are used in the drive side. Okay, so LV based series sensors are there. They are work on the Hall effect based sensor, and there are another as well, like the flux gate closed loop voltage transducer based sensor. So generally drives people use this particular sensor, but its cost is very high. So 4,580 you can see. So it's very costly. And another thing, its bandwidth is very low. So you can see the data sheet of this, so you can find it out that the bandwidth is very low. It's I guess 200-300 kilohertz, which are not suitable for our high frequency power electronics application. But if you are interested to work in a drives domain, then you generally see these sensors are used. Okay, So I guess I have provided you enough of information about the voltage sensor. What are the different voltage sensor we can use? There are some OPA based sensor, there are some modules as well, there are some isolated sensors as well, but we need some high bandwidth. What drives people use, those things we have seen and cover in this lecture. Okay, so thanks for watching this video. In the next lecture I will come up with the current sensors. Okay, what are the different current sensor we can use, how and where to connect in power electronics. So all these things we are going to discuss in detail. So thanks for this watching this video, and stay tuned.